Hi, students, and welcome to today's lesson. I'm Mrs. Davis. Today, we will explore the question, why do shadows change during a day? Are you ready? Grab your pencil and your science journal, and let's get started. We've been trying to figure out why the shadows in these photographs of the Gateway Arch look different. Today, we will conduct a fair test investigation using a lantern, a pencil, and modeling clay to model the sun's changing position in the sky. We will observe the shadow of the pencil as we change the lantern's position. Remember, we are investigating the testable question, how does the position of a light source affect the length of the shadow? In the first test, we will measure the effect of incoming light at 3 different angles. In the second test, we will measure the effect of light from 2 direct directions. And in the third test, we will measure the effect of 3 different distances between the light source and the object. In each test, we will change only one variable at a time and keep all other variables constant. We will collect data by measuring the length of the shadow, and we will conduct 3 trials for each test. Before we begin the investigation, let's make a prediction about how each variable will affect the shadow length. Which variable do you think will affect shadow length the most? Do you think it will be the angle, distance, or direction of light? Point to the variable you think will affect shadow length the most. I am so excited to see what happens. We will start with the lantern 10 centimeters to the left of the pencil at an angle of 0 degrees. What do you notice? The shadow is long here, isn't it? The shadow is so long, I cannot get a picture of the whole shadow. When I measure the length of the shadow with a ruler, the shadow is over 85 centimeters. The shadow length is also over 85 centimeters in trial 2 and trial 3. Next, we will move the angle of the light source to 45 degrees while still keeping it at 10 centimeters to the left of the pencil. The end of the shadow is still slightly out of the picture, but the shadow is much shorter this time. I measure a shadow length of 34 centimeters in all 3 trials. The length is over 50 centimeters shorter than in the first test. So, the length of the shadow decreased as we increased the angle of the light source from 0 degrees to 45 degrees. What do you think will happen when we increase the angle of the light source even more to 90 degrees? Wow, look at that. When I hold the light source at an angle of 90 degrees, the shadow completely disappears. I measured 0 centimeters in all 3 of my trials. Let's record that in our table. How interesting. Now we will test the direction of the light source. The angle of the light source will remain at 45 degrees, and we will start with the light source 10 centimeters to the right of the pencil. The shadow goes beyond the photograph again, but I will use the ruler to measure the shadow. The shadow length is 34 centimeters for each trial. Do you think the length of the shadow will change when we move the light source 10 centimeters to the left of the pencil? Let's find out. The shadow moves to the other side of the pencil, but the shadow length stays the same. In all 3 trials, the shadow measures 34 centimeters. Now let's test how the distance of the light source affects the length of the shadow. The angle of the light source remains at 45 degrees. First, we will put the light source 5 centimeters away and measure the length of the shadow. I measured 34 centimeters in all 3 trials. What do you think will happen when we move the light source to 15 centimeters away? Let's find out. Whoa, look! The length of the shadow does not change. The shadow length is 34 centimeters in all 3 trials. Did you predict this outcome? Let's see what happens when we move the light source to 25 centimeters away. The length of the shadow is the same. The shadow measures 34 centimeters in all 3 trials. Let's combine our data into one big data table. Does our data set match what you predicted? What observations of shadows did you make that our data set does not show? Maybe you think that the shadows are all the same shape as the pencil. That's true. And we don't have shapes recorded in our data table. Let's look at the data we did record. What patterns can we look for in our data? We can look for a relationship between a variable and the length of the shadow, right? For example, when we increase the angle of the light source, what happened to the length of the shadow? The shadow length decreased, right? So the shadow length decreased as we increased the angle of the light source. Let's compile our observations into a chart. We will use our data to summarize causes and effects. Let's do the first cause and effect together. The cause was an increase in angle of light, and the effect was a decrease in shadow length. Nice work! For your task today, you will complete this cause and effect chart. We've learned so much since we first observed the shadows in these two photographs. How can we apply our knowledge of light and shadows to help us understand the differences we observe in the photographs? Well, in figure 1, the shadow is longer. This means the sun must be at a lower angle in the sky. And did you notice that the shadow is very short in figure 2? What do you think caused such a short shadow? Do you think the light rays from the sun are hitting the arch from a higher angle? If so, I agree. We certainly have learned a lot about shadows. We will continue to use what we have learned to explain how the sun causes shadows to change. Let's review your task for today. Complete the cause and effect chart.